Green light, green light, green light. Green light, go. Here we go. Here we go, go, go. So we did this last, and like I said, unless you're Evan, you can see it in your cabeza because you're a genius like that. That's awesome. I like to draw the triangle out so that I can see all my pieces. I know, that's why you said it. So, I'm going to move back though and talk about that unit circle one more time. So, just pretend I drew the circle, okay? And I've got some angle here. But this is still a unit circle, which means that my radius is 1, correct? I've created what's called a right triangle. And I told you that this was x, correct? But I gave you another name, didn't I? What was that other name? Cosine. So this is technically cosine x. This would be sine x. Or whatever it is, sine theta. Let's do that instead. You guys cool with that? There was this relationship that you started to explore in Algebra 1, and you went further with it in geometry. And it was the Pythagoras thing. Do you guys remember Pythagoras theorem? What does Pythagoras theorem say? A squared plus b squared equals c squared, right? So I want you to take that idea and I want you to apply it to this. Create an equation, a Pythagorean equation, with this trig functions. Go. Same idea. Just create me a trig, a Pythagorean trig identity.
Cos squared plus sin squared.
You have one? Let's give everybody a chance to kind of think about that for a little bit. Oh my God! 33 people playing basketball? No, it was just me. That would be more than this class, bro. That was good though. That made me think about it. What'd you come up with? Sine squared, cosine squared? You said, let me repeat this. You said sine squared, cosine squared equals 1? Oh, plus. Anybody come up with that also?
Yeah.
That's so difficult. Yeah. Guess what they call that? They call that the Pythagorean trig identity. And it makes sense, doesn't it? If a squared plus b squared equals 1, then sine squared plus cosine squared equals 1. Yeah? So let me put this on a new slide. Sine square plus cosine square equals 1. I want you to create for me 2 more. I want you to create for me 2 more using your algebraic manipulations. Can you do that?
Wait, 2 more Pythagorean trigs or just 2 more?
I want you to create 2 more Pythagorean trig identities.
Using like the science.
And I just want you to kind of rack your brain a little bit.
Using this?
Yeah, using that. And your algebra skills. Okay, make me 2 more, if possible. You just kind of think about what could I do to make this different. Use your rules of algebra. Oh, excuse me, Mr. Bookshelf. Thank you, that's gonna help me a lot. I'll also put a square crack on my face. Look at you! Okay. Oh, I take it back. They are the best pen. I was gonna say this is, but it is the artist repeat. I haven't even paid attention to the name. I have it in black and I have it in blue. This is the best pencil right here. Okay, all this is just reflexive action. Why don't you do this one?
So I didn't do anything crazy.
Well, what is this for? You said. But this is kind of cool.
Mr. Munoz, I have my final answers.
Okay. Waterfalls. Thank you. I saw a lot of this, which is kind of cool. People went minus cosine square theta, minus cosine square theta, and now you can see that sine square theta is equal to 1 minus cosine square theta. So I saw that. That's cool.
I did.
On the same note, did you do the other one?
I did what?
Let me just put the other one up real quick. On the same note, that means that cosine squared theta would be equal to 1 minus sine squared theta, right?
Yeah, I did.
That's legit. Is that what you did?
No, I did 1 over secant squared plus 1 over
Let me-
secant
hold on.
squared.
Does anybody want to write these down? Those are cool. I mean, those are okay. And then I want to hear what else you got, and then we'll do yours first.
I'll go after Jay.
Your shorts are a little long.
Yeah. Oops. I have long legs. I did 1 over secant squared.
Hold on. Pause for a little bit. Anybody still writing these?
I mean, I don't know. I think I prefer them over short legs.
No, those are cool. I'm just harassing you. Because I thought they were pants for a second, but then they're like really long shorts. But oh, they're capris. There you go.
They're not supposed to be. They're supposed to be to the hair.
Don't make fun of her long legs. I understand. Just look at these are supposed to be pants.
Because you guys are tall.
Tall queens.
See, like me, when I used to ruin my pants, we used to get shorts. They would just rip, like, we would fall a lot into our knees, and just cut them, and you got tantarans. And you just, tantaran.
So, shut that.
Tantarans are awesome. What?
Bad. That was really bad.
Tantarans are
Why
awesome.
did you laugh?
You can do
Yeah.
Oh, karma.
Hydro down.
Hydro down. What did you do?
I did 1 over secant squared.
1 over secant squared.
Plus 1 over cosecant squared equals 1.
That's essentially what I did.
Essentially, I will this.
No, that's not cosecant.
Oh, I spelled it out because I do nothing with English.
That's pretty cool. What did she do?
No idea.
She did the inverse.
She just flipped everything. She just flipped everything. That's pretty cool. I like that. I like it a lot. You got something different?
Yeah.
Let me put this aside real quick. So she just did all the reciprocals on those, which of course would end up being the same thing. What did you do, bro?
So I got
You were
sine
on the right.
beta plus cosine beta equals square root of 1.
Well, that's not really different because the square root of 1 is just
Oh wait, yeah, never mind.
it's just 1, so that's not different. But it was a good attempt though.
Yeah.
It was a really good attempt. Thank you for sharing that. Anybody have something different? Anybody have something different? Go ahead, bro.
Cosine squared plus sine squared equals 1.
He used the commutative property
I also
to just flip the two. Okay. Hey, at least he did. What did you do, Blue?
Nothing.
Okay, then don't count on him.
No, I just love how simple that was.
Okay, then say that.
Is that sine? Couldn't you do like tan times sine squared?
Can I show you something real quick? I'm gonna erase this because that was really good though. You guys got that one down? All those things that you guys are making, you're gonna want to make sure that you can recognize them. Okay? You're really gonna need to recognize them. But I want to show you something here, and then you'll be able to make another one on your own. So the laws of algebra say I can do whatever I want to anything as long as I do it to, right? So if I divide everything by sine square theta, I have 1 plus
Oh, I forgot.
cotangent square theta is equal to cosecant square theta.
Wait,
I can,
but how do you even know? Like, did you just memorize that?
I have. I'm sorry. I've been doing it for too long.
Okay.
But this is why I kind of did this, so you can start to see a couple of different things. One thing that you should have noticed, hopefully though, is that just about every version of them had a square trig identity and a 1 in it. Did you guys notice that? Look back at what you've written. Everything, just about everything there has some square trig identity and a 1 associated with it. Okay? In your mind, that should spark, hey, maybe this is a Pythagorean identity, and I can simplify it to be a sine cosine equals 1 kind of deal. On that same note, what else can I do?
Wait. Divide by cosine.
Yeah, divide everything by cosine. That would give you tangent square theta plus 1 equals secant square theta.
oh, just kidding.
Okay? We're cool? Bum, 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 bum. Bum, 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 bum.
The world will be amazed when you find pants that are long enough for me.
That's really neat.
I can't find pads that are short enough for me.
Like, you can pull them up is the thing.
Short enough. I can get this one right now.
Alright, cool. So,
That's when you get like really
here are those Pythagorean trig identities.
those will be jeans on you.
Now, I do want to point this out. Some of the ones that you guys created are not here, but they're just as important. You need to recognize those things. You know, whether it's sine squared can be 1 minus cosine, or sine can be 1. Sorry, I said that wrong, didn't I? Sine squared is equal to 1 minus cosine squared, or cosine squared is equal. That's the same thing again.
I couldn't even
I have
say
bad memory, but all those things that you guys wrote are great.
Munoz, jorts will be jeans on you.
George would be jeans on George. Oh, funny.
Oh, you're mad.
No, you know what I wanted to buy as like a joke?
What?
One of those male rompers.
Ew.
You guys remember those male rompers?
Ew, I remember.
Just come to work, like backpack on,
I
a
don't
male
know what kind
romper.
of vibe.
I've never seen
Dude,
it.
we're all
They're I don't know if they're too short.
I hate rompers.
They're kind of like overalls, but they're
I don't like
it's a whole shirted thing. And
I haven't came in here in a long time. Except for us, if they're in the
a onesie without sleeves and hat legs. Yeah.
That was really mean, I'm sorry.
Yeah, oh, that's
I never like
It wasn't your face, it was just the way you're moving your head. I'm sorry. It's fine.
it's like a long shirt.
Okay. Using the Pythagorean identity. Thank you. Using the Pythagorean identity, given that sine t is equal to 1/2, and t is some angle between 0 and pi halves, find the value of cosine t.
Man, this just sounds so good. It doesn't make any sense. How are you supposed to plug in any value?
Mija.
Wait, I'm done. You just plug it in.
you,
I was like, what?
you just answered your own question.
Wait.
It was good. It's okay. It
What did
happens.
you say? Say it again. Say it again. I'm gonna repeat my dumbness twice. Okay,
And that
repeat
wasn't
the
dumb. That was
answer
pretty
part.
genius. You just kind of did it automatically without even thinking about
Too
it.
positive.
Got to be.
You're too reassuring. That was so smart of you to
It just kind of
to
happened.
redeem yourself.
It was as natural as breathing to you. Just,
All right, now you're just insulting.
oh, I'm sorry. I didn't mean to.
Give that sentence.
need a compadre?
Pretty sure, convince me that Mel doesn't have a candidate.
She's red.
Okay, not the marker dad.
I just want to let you know. I just want to know.
So you just take sign and any number between those two numbers given, and you find the value.
That's right now. You didn't know that. Morgan now goes here.
It doesn't make
No,
sense.
okay.
Yeah, when you left 10 minutes before you left.
She like, no, she left like 30 minutes.
That's what I'm saying.
Morgan was actually 30 minutes.
No, I'm just expressing how confused I am. So
She's gonna take over the office.
like, what are you gonna plug into cosine? It's just one. So is it just like where does that come from?
We're trying to find cosine.
Yeah, I know. That's cosine. We're using the theorem, right?
Okay, so what's the difference? Right?
Yeah, you plug in sine, yeah. Password, yeah. Plus, yeah. Yeah, okay, I get that. Okay, yeah. Oh wait, what's T? Is that just the answer?
No, that's the degree. That's like
Oh, theta, sorry.
Yeah. And then it's rest of four.
I know.
So wait, come back up.
How about I just do that?
What the heck does the zero less than that mean? Like, what does that mean?
Thank you. That's a good question.
That's a good question.
Waterfalls! I'm not sure for everybody. Waterfalls! So we have the identity, which is sine squared cosine squared equals 1, right? And I'm just plugging in the value they gave me for sine. Oh, I used theta, sorry. Should be t. So sine becomes 1/2. I'm still squaring it. That becomes a quarter. I'm going to subtract a quarter to both sides. That's going to give me cosine squared is equal to 3/4. I should just start from the beginning, yeah?
Yeah, so
Actually, yeah.
No, wait. Okay, yeah. Okay. So, and hopefully I use the right variable this time. So, sine squared t plus cosine squared t is 1, correct? We already know what sine is. What is sine? It's 1/2. It's up there. Sine t equals 1/2. So it's squared plus cosine squared theta is equal to 1. How much is that? It's 1/4 plus cosine squared t is 1. How do I get cosine by itself? Subtract the 1/4. So I have cosine squared t is equal to 3/4. How do I get rid of a square? I square root both sides. So I have cosine t is now radical 3 over 2. Now there was a fantastic question. Question was, what the heck does that mean? Well, let me sketch this for you, okay? I'm going to go here and back, and t is here. What's my radius?
130. Just kidding. 2.
And this is radical 3. And there's my triangle, correct?
Yeah.
Why are you going like... You're running me that mean with that. You're going...
Look at that little cat. He's like,
Let me.
Never mind, it makes
Yeah,
sense now. It makes sense.
Is this true, what I just drew?
I don't understand.
that is true.
Well, according to cosine, this is the adjacent side, and this is the hypotenuse, correct? So my hypotenuse is 2, and the adjacent, can this be the adjacent side?
No.
No, that's the opposite side. And this is a positive radical 3, is it not?
So we can find that one too, right?
I just drew it for you.
Huh?
I just drew it for you.
No, I know the one that's missing though.
Oh yeah, we could find the other one if we wanted to. However, here's what you need to know. Where's this angle located? This angle located is in the interval of 3 pi halves to 2 pi, isn't it? Do you see it?
No.
What position is this on my unit circle?
For my butt.
This is pi halves, this is pi, this is 3 pi halves, and that's 2 pi. So the angle that I drew that creates this triangle is between 3 pi halves and 2 pi. Is that where it's supposed to be? No?
Does the radius change if the radius changes too?
No, because radians is kind of a measure of this business, okay?
It's like the art.
Well, guess what? This Hey. I thought there was a bunch of them. I was going to take one of the little ones. Is my triangle correct?
Yes.
Should be?
I don't see why it wouldn't be.
Looks like it.
You don't see why it wouldn't be? Okay. Let me draw another triangle for you. The red one that I just drew. Does that not have a cosine of radical 3 over 2? It's the same, right? Do you see it, Blue?
I see it.
You don't see it? If this is angle T, what's the cosine?
Square root of 3 over 2 is 2. Square root of 3 over 2.
Oh, yeah,
So?
it is, because it's, yeah. It's adjacent over our...
Square root of 3 over 2. It's adjacent over hypotenuse.
Yeah.
So Evan, does that make sense? I've got two triangles, and they both have a cosine of radical 3 over 2. So, Maddie, which one is it?
Both. Question?
That's what that's for.
It is a good question.
Where should my angle be at? It should be between 0 and
Okay, that's still
Fine.
This still isn't, why does it have to be there, though? Because
So it's the top.
if they're the same, why does that need to be addressed?
You only want one answer, right? So it's the top.
So it's between, yeah, it's a top one, so it's between 0 and pi half.
this has less rotation on it, and this is the one we're after. If we were talking bearings, would you give this one to your captain to go? You guys know what bearings are? Sorry, that's why I said, do you guys even know what I'm talking about? Okay, when you're on a ship, you give your captain bearings to go to a destination. Bearings are like the directions, okay? You say, hey, set a course for 35 degrees north, 55.
You wouldn't really want to go all the way.
So, you've calculated for some reason in this.
Yeah.
Is this the direction you want to give your captain?
No.
Or is it the correct one? Okay, so you want to know which way to go. So in this case, the angle that we're looking for is in the interval from 0 to pi halves, which is 0 radians to pi halves. So that means it's in here. The other one was from 3 pi halves to 2 pi. This is not the one we're looking for. So what that's telling you is simply which of the two you want. Because the truth is, you will probably end up getting triangles that have the same values. For example, here's a triangle. It's called theta. Let's just go with 1, 2, 3. You guys cool with that? What's the sign of this triangle, guys? It's 2/3, right? There's another one over here that also has the same sign. But they're in two very different quadrants, are they? Okay?
So it's just to differentiate.
Which quadrant you're going to be in and which way you're headed, okay?
You wrote that one.
The sign on the side?
It's opposite over adjacent.
Yeah, so it'd be 3 over 2. Oh.
Here's my theta. Let's call this T.
Oh, that's right.
Opposite over hypotenuse.
That's to be 3 over 2. That'd be 3 over 2.
Oh, I put them backwards? JK, smiley face, LOL. 3 should go here, 2 should go there. So it should be 2 over 3. But I would have two triangles that have the same sign. So that's always going to happen. There will always be two triangles that have the same signs, the same cosines, What's up? The same tangents.
So theta and t, it's like the same thing.
It's just a variable. Yeah. If you want to call it like a smiler face or a little flower, it'd be okay. Uh-huh.
Maybe my Crayola.
Little picture of a lawn.
Sorry. You make yourself laugh too.
This one? You want the whole thing? To answer your question, Maddie? Simone.
That movie makes sense now.
I have those. My Crayola metallic markers. You wonder why I laughed.
Well, like, I don't hate it, but I hate the cursive. It just doesn't.
Jade?
Yeah, I can't make my name like pretty in cursive. It just doesn't go right.
Okay.
Well, like that's.
How do you do a G?
It's like this.
Oh, G. That she said. Like you hate G. I said like you hate the word like G. It's like, oh, jeez.
Do you watch Rudy Mancuso, Maddie?
Okay.
Do you watch Rudy Mancuso? He's on YouTube, guy. You reminded me of him right now.
Wait.
He does like all kinds of weird, yeah, he does songs and
Yeah,
weird
and he's
videos.
short and like Mexican. He has like that fake hair.
Yeah.
Yeah.
He did the one. Did you see the one where he died?
Yeah, remind you of that? That's cool. No, I
Well,
haven't seen that.
because you were saying G's.
Do I look like a G?
He dies and he doesn't go to heaven. He goes.
Oh, I've seen that one.
That's-
It's like the purgatory, right? Or like the middle.
It's heck, yeah. He goes to Kevin and then he goes to heck.
Yeah.
That's because you said G's. I like
Jeez.
it.
They used to
It's like we always switch those words a little bit.
Have you seen the one where he's like singing about his day and he like redoes it?
Like a groundhog kind of thing? No, I haven't seen that one. Where the day re-happens again?
Yeah, kinda.
I haven't seen that one yet. Okay. Give you about 30 seconds to refresh your memories on odd even functions. Not ringing a bell, girl.
It's not a very good one.
I
think I get it.
Is this an odd or an even function?
Even.
How do you know?
But the exponent's even.
The amount of sign changes.
Nice try.
The amount of sign
I,
changes.
that's a little shortcut that we use sometimes. I think you can use it well. But yeah, we're looking for sign changes, right? So this should have been f of x, my bad. If I change x to be negative, I should get back the same formula, right?
If it's even.
If it's even. If it's odd, what happens?
Changes.
When
It changes one.
all of them change.
All changes.
All of them change. And if some change and some don't,
Neither.
it's neither. Okay? Fantastic. Then here's what you need to know. Cosine is even. As a result, so is secant. Sine is odd. As a result, so is secant. Sorry, not secant. Thank you. Cosecant, as well as tangent and cotangent. Why would these guys be odd as a result of sine? Think about that for a sec. Obviously cosecant because it's reciprocal, right? But why would tangent and cotangent be odd as a result of sine?
Because you know.
Did you know?
You know.
You know.
Because like, yeah, tangent is y over x, right? And then like y over
Exactly.
negatives.
Exactly.
Wait, can you say that one more time?
I don't know.
Let me see if I can revoice this for you.
Yeah.
I'm trying out some of my talk moves here. So what I'm hearing you say is that because because tangent is y over x, aka sine over cosine. Since the sine function is in there, it's going to turn the whole function on.
Amen. I said that.
And since sine is already up.
Do you want to just repeat that?
I thought I did. No, I revoice, you repeat.
One time.
Well,
Wait.
okay.
Well, here, let me just say this one more time. Sine is odd, right?
Correct. Yes.
Tangent is defined as sine over cosine.
Yes.
Well, sine's in there. So, if sine is in here, it's going to turn it odd.
Shut up.
Shut up. Shut up. What a weird word. Or expression, I should say. Shouldn't you just like shut down?
Shutting down.
Shutting down. Sorry, updates installing. All by myself.
This is kind of like my go-to dance.
Good job. And then why it's called shut up and not like. Yeah, there you go. Boom, done. Put yourself up. Your information has to get handed. Good job. Yay! Good friend. Congrats.
I keep I don't know.
Oh yeah. I had him before this time. That's why
I had him last year. I just heard everybody want to be left out. I change it, Evan?
What do you think about this dance?
Everybody look at Evan. Use his cell phone in class.
Okay.
No cell phone.
no cell phone.
Okay.
Just point it loud.
A function f is periodic if there exists a positive number p such that blank for all t in the domain of f, the smallest positive number p for which f is periodic is called the period of f.
Say that so it's not.
See that in English.
Give me a second. So, you guys remember yesterday when we constructed the cosine function? It kind of did this bit,
Yeah.
right? And that went from 0 to 2 pi, correct? At that point, what happens? It just repeats, correct? So, how often does it repeat? So that's what p would be. And that's all it's saying. It's just the period. Period!
So once it's all like complete.
So if there is that such thing, then that would be p. If there's a point at which the function repeats itself, that would be p.
It's
So-
expressed in terms of pi.
Yeah. Not all of them,
Wait,
but
was it
the
a period, not a period?
say that one more time.
Was it a period, not a period?
Because I have Jeremy Naheda and he says period,
Oh,
but it's a period.
it's not a math thing. Got it.
You guys know Jeremy?
Yeah.
He's so funny. I love him. I love him and I hate him. I love him and I hate him. He's the greatest person, but he's as a student, oh Dios mío. No, he's not.
I'm gonna tell him that.
Okay. Tell him what?
You said that.
That he's annoying.
Okay.
Okay. So, for example, if I did have some, let's say I had cosine t, what is its period? 2 pi. So this would be plus 2 pi. Boom.
Okay. Is that?
What would it be for a sine?
Is it also 2 pi?
It would be the same thing?
Yeah.
What would it be for tan?
It would be smaller than that, I think.
Isn't it a half pi?
Yeah, would it be half pi?
It wasn't half pi, it was every pi.
No, it's every pi.
Because it went from negative half pi to a positive half pi, remember? So that
Oh,
period
yeah.
is pi long. Pi long. It's my homeboy. We kick it Fridays. Me and Pi Long go get a sushi bar. Here you go. There they are. Prettier than my.
So what is this sign? Just
It's just information, period. But now we're starting to construct the
Is it dog with the nails?
dog with nails.
And I was like, oops. Yeah.
Okay, maybe I don't know that.
It's like it's just a dog with like
Earrings and acrylic nails.
it's funny. In like the right context.
So it's a dog with nails.
No,
It's like
Photoshop.
Photoshop.
Do it. Try to draw it from memory.
Wait, you can change the color to the brown.
Jade,
Yeah?
what's the bad guy from Megamind's name?
What?
What is that?
What's the bad guy? The reporter that turned evil in
Oh my god.
It's like, it's owl or something like
It is
that.
owl.
Yeah.
That's so
Does he not have a super
Dude,
hero?
That's the term.
I'm your grandfather. I'm your slave.
But that's a dog. Wait, you need the hoops.
Oh my god, why is that so big?
He's doing pancakes right now, dude.
Oh, here it is.
No, it's big caps.
What are the green things?
That's their earrings.
Oh.
Oh, yes, here it is.
That's what it looks like.
That's pretty accurate if you ask me.
I've never.
I'm gonna save this forever. I'm not gonna delete
Save
what's
it
on.
on that slide so next year.
I'm gonna save this.
That's so good.
When like the photos are relevant.
Here's your tangent, cotangent period. Oh my god.
That was good. You didn't even look at a picture, Maddie. I was so impressed. What can I say?
Natural. Ever look at Kennedy use her phone?
Oh my god, dude.
Come out with Lauren.
What?
I said more like Candy has her face ID of my phone so she can unlock it whenever.
That's funny.
Yeah, I never.
Or something stupid. You said something absolutely stupid to my friends. Because I have weird reasoning for my friends.
Okay, here you go. Some practice. I want you to evaluate or find the value of each trig function, please.
7.
Cotangent 5 pi fourths and cosine negative 9 pi fourths.
What's the value? Good.
What?
How we find those?
That's what you're after.
I know, but why? Like, what is it? Never mind. Let's do math.
I'm confused.
Two.
I am Confucius.
Don't go through my stats, please.
Evan, ask your question one more time.
Oh, it was Hal, not Al.
How?
That was close. Thank you.
What are we trying to
Played by.
You're trying to find the cotangent of 5 pi fourths.
Oh, okay.
If I'm not mistaken, it's
If we go.
It's numbers.
It's gonna be a pie,
Don't
right?
finish it.
no, it's not. It's a negative one. Negative one.
What the heck? Oh wow, I got it.
Right. So it'd be pi. Yeah. Oh wait a minute, it's positive. So no, yeah, negative one. You get negative one.
Oh my god, you suck at everything.
No calculators. Do it by hand.
No cap. You won't
Do it by hand.
You're right. No cap.
Now I do it.
No cap.
Told me that before the calculator.
Yeah, I don't even get like orders.
I don't know how the calculator.
No. Put those calculators aside. You know what? That's what I'm gonna do for homework then. I'm gonna have you guys graph a bunch of these. Guys, where's 5 pi fourths at?
Uno.
It's not here. That's pi halves. Is it here? No, because that's pi. That's 4 pi. 5 pi fourths is right here. Here is 5 pi fourths.
That's what you mean.
You want to find the cotangent of it.
What?
So 5 pi fourths ends up right here.
How?
Bruh, because it's That's the radius.
This is pi halves.
Okay, yeah.
This is pi.
I didn't even do super.
If this is pi, then that's 4/4 pi. Right?
Okay.
If I go to here, what is this? That might not even be the right one. If this is 4, this would be 4.5. Maybe I have it wrong.
That'd be 6. No, 6 over 5.
Yeah, this would be 6, wouldn't it? So this would be 6/4 pi. So 5 pi halves is right in the middle, right here. Right here. If you want to translate it, technically that's going to be in a 45-degree angle, isn't it?
45.
Okay? Now, if you guys remember from your 45, 45, 90, what are my side lengths?
Square root of 3.
1,
X,
1,
and radical.
radical 2.
I was close.
1, 1, radical 2. Now let's just stop and think about this for a second. Can this just be 1? We know it's a distance of 1, but can it be 1? Which way did I go on my x-axis? To the negative side. Therefore, this is -1. And this is a -1. And that's just radical 2. This will never be negative, guys. Just an FYI. So if I want cotangent is defined as the adjacent over the opposite. What's my adjacent side? -1. My adjacent or my opposite side? -1. What's that value? 1. So what's this equal to? 1.
So you pretty much just find it on the unit square and then you go.
And then you figure out what that triangle is. It's either going to be a 30-60-90 or a 45-45-90. Almost always.
So it's either always going to be 1 or
No,
with negative, you have to go up.
it's not always going to be a 1 or -1.
I wish I had a beard.
I wish I didn't have it anymore. I
There was
think
this one kid show where this guy had this like goatee and he was always like this. And as like a 5-year-old, I was like, oh, God, I wish I had one.
Evan, why isn't it always going to be 1 or -1? That only happens when you have a 45-degree angle.
Especially pedestal.
There are 2 other angles out there. 30-degree angle or 60-degree angle.
Oh, 60 degrees like this.
He's in exception.
Evan, even with the 45-90s, there's a radical 2 in there. So sometimes you're going to get radical 2 over 2. Right. Does that help a little bit?
30, 30, 60. But what's the other?
I want you to do this one for me. Now, please be careful. This is a negative angle. And then we're just going to do a bunch of those. Square root 2 times square root 2 is 2. Yeah, I have those too.
Oh my God.
It's 60 times 2 get oh, that's what I'm nervous about.
Oh, find it.
No, that's not.
Waterfalls. See that again? It's gonna become mine. Tomorrow we'll practice a little bit more on this. I think you guys are a little bit confused on what to do with your angles. But here's what's happening with this guy. And guys, if something does confuse you, need to let me know. Damn it! That's what you're saying. You know how many times I kicked that box today?
I know I don't.
Too many. Where do I start?
You're gonna go counterclockwise.
Where do I start? At 0. Now, if I do 1 full revolution, that is 8 pi fourths. Negative. I have to go another quarter, don't I? So that means I'm going to end up right here. So that's where I stop. Please watch. I'm going to create my hypotenuse. From that point, I'm always going to come back up to the x. If I'm up here, I'm going to come down to x. But this, my friends, is now theta. If that's a quarter pi, that means this is a 45-degree angle, which means I've got 1, -1, radical 2. This is the angle that I'm going to use the whole time to create that. So what do I want? I want the cosine, which ends up being 1 over radical 2.
You can simplify it, right?
Tomorrow we'll graph a bunch of... What's up?
Just 1 square root of 2.
1 over radical 2? Yeah, if you want to rationalize it, that's
What
cool.
would you rationalize?
Radical 2 over 2? Radical 2 over 2?